Okay, so I wanted to go over this script for the summarize a data set project and in general to show how to calculate the three types of frequencies that were reviewed when we're summarizing categorical data. I'm gonna actually comment out, which means I'm not gonna run these two, but let's focus on this one. Tidyverse, a good reminder why we run the library. Tidyverse has a lot of functions that we use, ggplots in there, mutate, these label functions, for instance, that you may have seen, are all functions run in Tidyverse. It's a sort of data management and data visualization package. And so we open up R and we say, hey, just so you know, we need to take this library book out. We need to go through these functions and register them. If I was running something in psychology, I'd run, it's kind of cool. We could look at some of the different packages here. If I wrote something like psych, well, that didn't show up. Geo, so there's something for spherical geometry operations. Let's see, there's some natural language processing, all these different packages, but most of the class we're going to rely on just Tidyverse. So we've run it. I press Option Enter when I run library Tidyverse, and it shows up in the console. I'm using an R script, not an R Markdown file. This isn't too serious, right? These are just some notes, and so I don't need to knit it, for instance, and have this very nice document. I'm just running an R script. So if you went to new R script, you could do this. You can see I still have comments. So essentially, it's like just having the code block and nothing else. First thing I'm going to do is introduce the data set. Again, press Option Enter, or I could press this Run button. And I run this line of code, Titanic dataset, read CSV, and here's the link. I've uploaded to Canvas that shows the Titanic data set. If I want to get a good idea about it, I could go I could do a glimpse, right? Or I could do a full view. I've actually already run that, and it's right here. All the people on the Titanic. Okay. So to make the two-way tables, we use the table function. Table is not a function within the tidyverse. It's within what we call base R. So basically, it's pretty based, if you will, but the base R functions exist in R already. So I wouldn't have to run a library to, for instance, find the mean of Titanic data set, cash money, fair, right? It would already be there. So tables just like that. And if I run table and I pick my two categorical variables, passenger class and survived, and I run that, this is what I get. And you can see that there were, for instance, 80 people who died in first class, 136 in first class who survived. Remember that actually, that other variables survived. This is for a two-way table. If I wanted just a one-way table, super useful function, I just put the one variable in there, and it shows that there were 549 people who died and 342 who survived. If I nest my table function, within the add margins argument, I will get margins to my table. So these are the tables you've grown a bit more accustomed to, where you have the sum, for instance, of the columns and the rows, okay? And there are ways to sort of do this in R, but I don't know if I think it's less complicated to just kind of do it manually and use R like a calculator to do some of these probabilities. So first you have your marginal probabilities, and you can see I put a little definition here. The probability so this is, rewind. Marginal probability is the probability of an event irrespective of the outcome of another variable. So for example, the probability that you survive if you're on the Titanic, irrespective of your passenger class. So then we go and you say, okay, well, 342 people survived out of 891. Notably, both these numbers in the margins, hence marginal frequency or marginal probability, okay? So if I run 342 divided by 891, I get 38.38%. Okay, so not great odds. The joint probability is the probability of two things occurring at the same time. Okay, so what's the probability of being in first class and surviving? Okay, in that case, when we turn to the table, we see the probability of being in first class and surviving, and that's 136. And in this, and I'm going to emphasize this here, our denominator is 891 for a joint probability. Okay, it's probability of two things happening. And so what we're thinking about is all the things that happen for variable 1, all the things that happen for variable 2 over all of the variables. Okay, so that I need to contrast with our conditional probability, which is the probability of one event happening in the presence of a second event. So in that case, we change the denominator. So if you're in first class, what's the probability of you surviving? That's conditional probability, which again is different than what's the probability of being in first class and surviving. Okay, the joint probability, what is the probability of all possibilities for you to have both of those data variables, right? The joint probability uses the denominator of all individuals, so 891, versus the conditional probability, if this condition is met, if you're in first class, of which 216 people were, hence it's our denominator, what's the probability of surviving? And that's 136 over 216, so 62 point, probably 63% is what we would round to, okay? Hopefully this is helpful for this assignment and your preparation as you understand these three different frequencies. Thank you.